Hello, what we're going to do here in this video is work an example of a classic related rates problem where we have a triangle and the dimensions and the area of the triangle are shifting and changing. So let's go out and get a good color here to write with. So here's a triangle and let's check it out. Okay, so I'm going to indicate the height. And I could call it either by height h. I need to assign now variables. I could either call the height h, or perhaps I could use y. I guess I'll use h for height. And then I need to have the base. I'm going to have the base b. B is the base of the, the whole base, this whole line segment across there. Height, put that a different color, maybe green. There's height right there. Height. So some people say height, but height. Okay. Okay. Well, let's write down some facts that are given, and let's see what we have given here. So I drew a figure, which is always a good idea when we're doing a word problem. All right. So let's look at what we're given. Apparently, we're given that. Well, let's read the problem. The altitude of a triangle the altitude of a triangle is increasing at a rate of 1 centimeter per minute. So that given means that the altitude h is changing at 1 centimeter per minute. And what I do is I put this in calculus language. When we say that the height is changing at 1 centimeter per minute, that means the rate of change of height with respect to time is 1. That's derivative. dH/dt is 1. It's constant 1. While the area of the triangle is increasing at a rate of 2 centimeters squared per minute. So that's another given. The rate of change of A for area is equal to 2 centimeters squared per minute. And because they're both increasing, when I do write down these derivatives, I write positive numbers. dH/dt is positive 1 because it's increasing at 1 centimeter per minute. dAt is positive 2 because the area is increasing at 2 centimeters per minute. So if they were decreasing, we would put negative. Then, what are we trying to find? Let's make a special little thing over here. We can put it anywhere we want on the paper. We're trying to find what? It's saying, at what rate is the base of the triangle, that's B, changing? At what rate is the base of the triangle B changing? So that's the question of what is the derivative of base with respect to time at the instant when the altitude h is 10 and the area A is 100. Let's write it down. So put this in calculus language. We're trying to find the rate of change of B with we're trying to find dB dt, the rate of change of the base with respect to time when the altitude h, when the altitude is 10 and the area is, when the area is 100 centimeters squared. Well, I guess I'm using a darker color there. I might as well do it here too. Okay, see it, maybe see it better. All right, so then I feel like I need to make these even darker. Oh well. Okay, so now what we're going to do is write down any formulas that we have. Well, we do have a formula that we know about for the area of a triangle. Well, where the heck does that come from? Well, a triangle is half of a parallelogram. So that's where this formula is coming from. Area of a triangle. So A for area is equal to what? Well, for a parallelogram, the area is base times height. But since it's half of that, do you see what I mean by half of that? You see, you got this one right here. You could copy and paste a version of it over here in our triangles, half of the parallelogram. So the formula for a parallelogram area is base times height, and this is 1/2 of that. Okay, that's an oldie but goodie. And now what we're going to do is find the derivative, and we do the derivative before we put in a as 100 and h is 10. And all these numbers, we don't want to put h as 10 and a as 100 because a is changing. For whatever reason, this is not just a triangle that's sitting there. It's a growing triangle, apparently. The height's growing and the area is growing. So something's going on with this triangle. It is not, maybe I could demonstrate by this program here. It's growing. See, it's somehow it's growing. Okay. So we're going to take the derivative, and the derivative is a derivative with respect to time. And so I write d dt, derivative with respect to time. On the left, that's d dt of a. The right, d dt of 1/2 bh, base times height. Now, for the left-hand side, it's just dA dt. There's nothing more to it than that. So on the left-hand side, we just write dA dt, and we're going to fill that in later. For the right-hand side, we have 1/2. We have a constant times a function. We leave the constant alone. And then what I'm going to use is the product rule because I have base times height. So in the product rule, I take the derivative of b first, actually h first, whichever one. I'm going to do b first. I could write b prime, totally legitimate. I'm going to write dB dt, but b prime is also good. But then I leave the second guy alone, the second gal, whichever that one is, leave it alone. Then let's leave b alone, and I take the derivative of h with respect to time. See, that's the product rule. And then what I do is I fill in all those things, all those pieces there. I'm going to fill all those in. Fill in. What am I going to fill in? Well, I was given a bunch of stuff. You can rewrite it or not. I'm going to fill in dH dt. It's sort of a waste to rewrite it, but in dH dt is 1, dA dt is 2. See, I'm going to fill in dA dt is 2, apparently. dH dt is 1. Actually, I'd have to say one thing that's an issue with my h and b is that I never really thought of that, but h and b could possibly look the same. I'm going to put a little loop on my h's. They look a little bit the same. Okay, so dH dt I put in 1, dA dt I'm going to put in 2, and also I'm going to put h is 10 and a is 100. Oh, I don't need to put a as 100. Oh, but I do. What am I trying to find? I'm trying to find dB dt. And in order to that, I need to get b. Okay, let me just tell you what I mean by this. Okay, so we're going to put in h equals 10 and a equals 100. Let's put all those in there and keep in mind what we're trying to find, which is dB dt. We're trying to find this guy here. So dA dt is 2. Then we have 1/2. dB dt, okay, good, times h, that's 10, plus b times dH dt, which dH dt is 1. The thing is, I'm trying to find this dB dt. This is what we're trying to find. Let's put a little like, find this. But there's this other part here. This other part here, I also need to fill in. So the question is, what is h, or sorry, what is it? What is b when h equals 10 and a equals 100? See, we're filling in a is 10 and h is 100. I think we can answer this question. How are we going to answer it? We are going to use, so this is an aside, our little snapshot. I'm going to use a equals 1/2 base times height, and I think this will be not so bad. I'm going to take a is 100. I'm going to put h is 10. I'm going to put those in there, and I'm going to be able to find what h is at that instant in time. So 100 equals 10 divided by 2 is 5h. So 100 divided by 5 is h. Long division, I hope, do we have to use a calculator? Anyway, that's 20. 10 divided by 5 is 2, and you got the 0. So so we get that there. So we have that, and we bring it back, put it inside there, and I'll just go ahead and do that. I'm going to put in 20. Okay? And so then I'll continue on this the same little problem here. Okay, it's going to keep going on this. Snail track down to there. Change up the color to something a little darker there. Okay. All right. So what I can do is different ways to solve this. I could, probably the easiest actually, be multiply both sides by 2. It's not going to be too difficult to see. But if I have, it's a little bit messy with the stuff. But if I have 2 multiplied by 2, it's 2 times a half, which of course cancels out. To be dt times 10, change the order, right? Plus 20. So these guys cancel out to the point where I don't even want to really put them there to show that, but I multiply both sides by 2. So therefore I get 4 equals 10 dB dt, but you know, this is really just algebra here. Does that make it easy? Some of those algebra problems from beginning algebra are super difficult, I think. Okay, then we'll divide. I feel like some days my handwriting is a little neater than others. 16 and 10 have a common factor of 2. But some people actually might want to write this as a decimal. 16 divided by 10 is easily written as 1.6. So it's negative 1.6. But you could also write that as negative 8/5. And then someone will say, well, which one do you want? Well, they're the same. I don't like a decimal that's rounded off, but that's the exact value. And so, and what were we doing? Centimeters. The rate of change of the base is, it's the numerator centimeters, or not the numerator, but anyway, the b is in centimeters, time is in seconds. So that's centimeters per second, or you could write the centimeters per second. And then, seems like that would be the answer, but I think you might say that, might want to write it out. The base is shrinking or decreasing at a rate of 1.6 centimeters per second. See, I got rid of the negative when I say it's in shrinking, or you could say decreasing. That is the negative there, but maybe just leave it what I highlighted. When the height is, okay, do I need to write all that down? I feel like it's too much. It's 10 centimeters, and the area is 100 centimeters. You could write in a little, it depends sort of on your teacher, whether you like that. Do you need that little, do you want that little paragraph there or not? Okay, that's, that was it. It took 2 pages. It's a classic problem though. That's all for this video. Thank you. Goodbye.